Still a few people. So, GitOps. Has anyone heard of the term GitOps? I hadn't before I started this, but apparently it is a thing. I'm assuming you're all writing PowerShell in some way, shape, or form. Who is putting their PowerShell into a Git repository of some description? Lots of people. Okay, that's good. So yeah, this was sort of the journey I took from when I started becoming a system administrator, writing PowerShell scripts, to how it. I think Daniel started it, yeah. And how, as my abilities grew and the scripts I was writing grew, the need for having source control and version control. And it's kind of, if you're not writing PowerShell and putting it in Git, then this is kind of why you should, why it's a good thing. The benefits are going to come from it. And hopefully you'll pick something up and start using it. So who am I? I am a live services specialist at Sage. That is effectively doing DevOpsy things. We're responsible for all the live services across most of the European products, all cloud-based in Azure or AWS. We're doing the DevOps. Isn't everyone? I've got about 5 years PowerShell experience. That number fluctuates based on my maths, but it was around 2014 when I started writing PowerShell. I'm an accidental DBA as of this year. Thanks, Shane, for forcing that one in. I had no previous SQL knowledge, but when I joined Sage, they went, you're going to have to learn it because we've got 13,000 databases for you to look after. So, trial and error, lots of oopses. I infrequently stream to Twitch, and there's a group of people who are doing PowerShell streaming. You can follow that on Twitter, and it tweets out when people go live. There's also like live coders, which is like the equivalent, but they do like all sorts of languages. And these are the Slack and Discord links. If you're not in them, there's a UK-based one and there's a global one. And there's people in there any time of day. So if you're writing scripts at 2 o'clock in the morning, there'll be people on. If you've got a question, jump in there, ask it. Really friendly community. A lot of faces in here are already in there, so get involved. So basic agenda. What is Git? I presume you've all heard of Git. If you haven't, this session is not going to get you out from under that rock. What is GitOps? Like I say, I coined this as sort of a joke and then found that it was an actual thing. So we'll quickly cover the actual definition of it. Why Git, why you should be using Git, the benefits it will bring. We'll cover the basic Git commands that will get you started, and then sort of how you can progress from there as well. I'll show you how to create first Git repository, and then we'll go into sort of branching as a thing, not so much a branching strategy because that varies wildly depending on who you speak to. So what is GitOps? GitOps is the technique of using Git pull requests to manage infrastructure provisioning and software deployment. So if you're a system administrator like was in my role, the first sort of stuff you'll look at is configuration management, whether that be DSC or Chef or SaltStack or Ansible or any of the other flavors that are out there. When you first start using it, you'll probably do what we did and just build a Windows server that hosts your pull server, and all of your configs sit on there with access to whoever has access to that server, potentially being able to play with your configuration files. So starting to use Git was, for us, a way of controlling who had access and what was being changed and being able to audit that. Using Git is a single source of truth for declarative infrastructure and applications. So by using Git, you remove the complexities of managing configurations on servers and putting it into a place where it resides, and you know that when you go and look at that, that is what should be running in production. Leveraging Git to create visibility of work, make tasks repeatable and automated, encourage collaboration between teams. There's lots of DevOpsy type words in there: visibility, repeatable tasks, automation. But it's sort of Git is sort of the pane or the viewing window into that. When you start using it, it makes collaboration easier. If your colleagues can see your code rather than just see the output of it, they may come up with some ideas, they may start contributing to that, and it creates a better collaboration across teams that previously wasn't there just by creating that visibility. And yeah, so one of the easiest things to get started with is the configuration management, because you already know how to do it. You just have to translate that into code. You're already probably doing it as a manual step. Make a note of your steps and then transfer that into code. That's the easiest way to get started. And then it removes human error. It makes it repeatable. And once you've got it into Git, people can actually start contributing to it with pull requests, with code reviews, with just even pointing at lines and saying this looks wrong. Whereas previously they're not going to be able to do that. So that's the official-ish term of GitOps. I removed the branding because it's apparently Weaveworks came up with the definition. And then there's a couple of GitOpsy type things, but it's all around managing Kubernetes from an ops and dev perspective. What is Git? This is the official Wikipedia description. I'll not read it to you. I don't want to read that slide again. What is Git in sensible English? It's a way to create little waymarkers or save points at the points in your code's history. So every time you commit something to Git, you're saying, I want to save where I was here, and it should generally be in a working point of your code so that you can reference it, look back on it, see what changed the next time you go to make a change. As you check in your changes, you'll create a log of your history. So that's the other crucial thing to Git. Every time you do it, you get a log of what was changed, when it was changed, who changed it, and all of that other good stuff, which gives you auditability and traceability for when things break. Git is not GitHub. They often get used interchangeably. They often get confused. But Git is a tool you install on your device, and it allows you to write code and do the commits and get all of that good stuff out of it. GitHub is a place which integrates with Git and is a platform to store your code. And it's basically wrapped around Git. Not to confuse the two, because I think a lot of people have spoken who are like, Git, yeah, that GitHub thing. It's not the same. So why Git? I've covered some of it already, but the things you get from it straight away out of the box are access control. So you set up permissions on who can change code, who can read code, who can contribute to code. You can even set it up on a file share. You don't need GitHub or GitLab or Bitbucket or whatever. You can set up a UNC path as a Git repo to get you started. Or, like I do 9 times out of 10, just run it locally on your laptop. Version control, I've touched on. So you get those waymarkers in your code to say, this happened afterwards, and it increments the number so that you can reference that. Distribution and visibility, I've touched on already as well. But as soon as you start using Git, especially with remote repos, you can start distributing your code across your network, across public domains, if your stuff's open source. It will accelerate your career. It's a bold statement, but it shows that you've got a familiarity with the software development lifecycle. If you're using Git as an administrator, and you want to start moving into a more DevOps-focused role, if I was looking at CVs and I seen somebody who was already using Git, using GitHub, based on somebody who was just writing code, that one would stand out a lot more to me because it was evident that they were aware of the processes used to manage software. And it will save you on occasion, and it has done for me. I pushed a change into production a while back, which, I mean, I could just do a whole horror stories one if you want. But it ended up with a merge conflict, and me not looking at what it was like, that's the right one. Accepted the incoming change, which then broke things catastrophically. But because it was in Git, I just had to revert the change, and everything was magically fixed most of the time. The basic Git commands. There's hundreds of them. You won't use them all straight away, but 9 times out of 10, these are the ones you'll use regularly on a daily basis, even if you're just using it locally. Git push, I deliberated with putting in there, but this is more around separating Git from GitHub and looking at Git. Git push does feature a little bit later on, but that's managing Git, the commands you'll use. So, creating your first Git repository. It's effectively a file system, it's a folder. So you'll create a folder. This is my way of mitigating my terrible typing. Nobody needs to see how many backspaces I press. You'll move into that folder and you'll run git init, which will initialize that folder as a Git folder. Locally on your file system, it will have a hidden folder in there called .git, which contains all of the metadata for that folder. The version history, the changes. You can go and mess around in there if you want. I probably wouldn't change anything. But that's all you need to really know about that folder. It just contains the stuff that Git needs to manage that folder. Add your scripts to it. You can initialize Git in a repo in a folder, which already has files in it. You don't need to start from fresh. So if you've got a folder on your laptop, which is my awesome scripts that are all coupled together, stored in ctemp, you can initialize that as a Git folder just by running git init and then start tracking changes. Git status is the next one, and you'll run that a lot to see what your status is. So we've added the files into the folder, we've ran git status, it's telling you you're on master branch. So when you initialize that folder with git init, you always get the master branch. Master branch can be called something different if you really want, but out the box you get master branch. It's telling you you've got no commits because you haven't made any commits to that folder, and that you've got untracked files. But then it even tells you how to add files, if you can see that at the bottom. So use git add to track these files. Git will only track the files that you tell it to track. It won't automatically look at everything. You could initialize a folder, still work away on it. If nothing's being tracked by Git, that metadata in the .git folder isn't going to change because it doesn't care about those files. Staging changes in the index, which is what it told you to run in the last slide. Git add dot adds all of the files that appeared in that list. So if you've got 300 files in there, git add will add all of them to the index. If you notice now, though, when you run git status, those files are green. That means that they're now being tracked by Git. You've told it that you want it to know about those files. The next logical step after that, my animation doesn't work the same as the other slides, apparently. You want to commit your files, and the -m is a commit message, which will appear in the logs when you look back on it. It tells you which branch you're on, and it gives you a SHA-1 hash in there, which is made up of got a message, author, committer, parent, and the files. So because the SHA-1, it needs to be unique, it builds that based on all of that metadata in there, so that when you go through your logs, you're not going to have duplicate entries in there. So you run git status again, it tells you that you've committed those files, you're on the branch master, and there's nothing to commit. Your working tree is clean. So I can't do PowerPoint animations apparently. That's your local folder, or workspace, as it's defined in Git. When you run the commands, this is what it's actually doing. The workspace will have tracked and untracked files in there. That's just what's in the folder. When you run git add, it's adding those tracked files, staging those changes into the index. When you run git commit, it's adding that to your local repository. Folder, repository, often interchangeable as well. It's not technically a repository when you initialize it. Semantics. Call it what you like. Or you can also do commit-a, which will both of those together. Commit, add all of the files, and then you just put your message on the end of that as well. And then this was, if you wanted to push your changes to a remote repository, you use git push. And all that does is sync your changes from your local repository to GitHub, Bitbucket, UNC path, wherever you've got your remote repository. So using Git Log to see our commits. That's what a log entry looks like. That's the full SHA one that you don't always see. You generally get the first portion of it when you see in the other parts. It tells you the author. You have to set an email address up and a name up in your git config when you start. And it's literally just git config username. And that'll set it globally across. If you can set it globally, or you can set it per repo, which gets complicated if you've got work and personal stuff. Tells you the date that it was changed, and then what the commit message was when you committed it. So branching. There's two paragraphs of different colors. So branching, you'll hear branching strategies talked about quite a bit, especially in dev arena. And it's very opinionated in what works and what doesn't work. When you're first starting out, you need to think about how you're going to work. So I'm going to cover briefly a simple way to do branching, which worked for me. It might not work for you. It might not work for your team, but it'll cover it anyway. So branching allows you to have different versions of your code simultaneously. So you've got your master branch, which I highlighted before. You can create a branch, and all it does is put a pointer at that location in your code, and then you can veer off from that, and master is intact. You can have as many branches as you want if you really want to get into trouble. But branching means you can add features or fixes without impacting anyone else using your code. So you can have your code on a server running your configuration management for desired state configuration working. You want to change something, you want to add a node, you want to do something to that code. Previously, in my earlier days of being a sysadmin, I would just go copy, paste version 0.2 because that's how we do versioning, by file name. But using this method, you can branch off. Git keeps track of what files are in there, and unless you merge that code back into master, it's not going to deploy that code. For me, or what worked for me at least, is keeping branches short-lived. I worked somewhere previously where our master branch was a dev branch. We had a master branch, but everything got tested in dev. We weren't sure if it was going to work in master, so we ended up just using dev as master. So we eventually merged everything into master, and then stuff in the US broke because we hadn't taken everything into account. So use a branching strategy, do your testing, make test for all cases, then merge back into master to make sure things work. And because everything's in Git, even if things break in master in production, you can revert those changes. Whereas previously you then have to go, what did I change? Did I put comments at the top of my script with a change log saying I changed line 62? Probably. Isolate your code. Don't get carried away doing more than one thing. I put a pull request in recently for the ServiceNow PowerShell module, which was supposed to just add OAuth to the credentials, or to the authentication. And then I got trigger happy and changed all the parameters and was like, this doesn't look right. And then put the pull request in, and then the guy who maintains it came back and went, why are you changing all my code? So I set about just trying to make a small change, which turned into a very big change. But then I also got trigger happy and started changing other things, and it just ended up having to go and fix it all and rewrite the history and doing lots of Googling on how to do things in Git that I'd never touched before. So just try and concentrate on one thing in your branch. Call it something sensible like feature, adding OAuth. And then once you've done that small feature, raise a pull request and merge it back in, or just merge it back in if it's something local. Commit often and use meaningful messages. Added stuff and work, damn it, are not useful to future you. If you've worked with CI/CD pipelines, this is all you use. Trying to define your YAML and white space variations. I started using emojis at one point last week because it was more fun than just writing. It's going to work. Learn the basics of Git and agree on a way of branching that works for you and your organization. Yeah. It depends entirely on the product we're working with. If it's a personal project, I'll set up a Azure DevOps pipeline to do the releases, and then I'll have the pipeline run when a pull request is put in from another branch to run tests, and then make sure all of that passes before anything's merged in. So there's the 100 million different ways of doing it, and it depends entirely on which way the devs are doing it. Sometimes we don't even have access to where they're doing the build. They trigger a webhook to pick up the artifacts and do a release. Some stuff we do the full end-to-end process. So it depends entirely on what we're working with at that present time. But you can trigger off branches, multiple branches, if you can set flags in your CI/CD pipeline to only trigger on certain folder changes. So if you're working with a colleague on two things, you push a change to a folder, you can say, I only want the pipeline to trigger on that folder being changed. So it's really flexible. And a lot of the tools that are integrated around Git give you that flexibility to work how you want to work effectively. So create a new branch. That's simple. Git branch, new functions, Git branch. Remember to check it out afterwards. Otherwise, you'll be still pushing stuff to master. I tend to use a variation on that of git checkout -b, because it creates a branch and then checks it out for you, so that I can't accidentally push stuff into master. Otherwise, you then have to go and fix your mistakes. But git branch and name, and the amount of times I've named something 0a, trying to do git branch all to have a look at them all, and miss the hyphen and press 0 instead. So it will take anything you put in there, so just be careful. Check that branch out. My screenshot's wrong. That star should be on new functions and in green. Duplicating slides. Yeah. So it's just a pointer saying you on that branch now. Add your new functions on this branch. Stage the changes to the index again. Git add and git status, function 3 and 4. On branch new functions. I updated that one. Animations are hard, man. Another commit message, meaningful commit message, added function 3 and 4. git status will tell you that you're on branch and you've nothing to commit. You've just committed those 2 functions to your new branch. So that's effectively what it looks like. So you've got, I mean, you could start it wherever. You could start by adding, you can start by creating a branch and then making your changes depending on how you initiated your Git folder in the first place. But say you've got a working master branch, branch off from that, make your changes, add them to the index, and then commit. And then you can go back to branching. If you've got another one, merge it into master. That bit is up to you, depending on how you want to work. But that is the 4 things you'll do religiously when you're working with branches. You can merge it into master locally, so I'm running an ad hoc folder on there with just stuff in it that I like to keep locally, and that's a Git folder. And I'll make changes on a new branch, commit the changes, and then merge it back into master. But it means that I can mess around with things on there and see what I broke and then revert it if I've broken something that unintentionally. So I've got a little demo. It's not really a demo. I was just going to go over some stuff and show you how it interacts from the command line. This might be a bit difficult with my head in the way. So I've got a folder. That big enough? My prompt is too long. I'll keep it. Because that's shut down. So it's hibernated, and then the prompts come back up with how long it took for me to turn my laptop back on. Right, so I'm on the new functions branch. You'll see in there I've got function 1, 2, 3, and 4, because that's what I just committed. It's all right, it's black at the bottom, isn't it? Because I haven't merged those changes back into master, that folder is still only got function 1 and 2 in it. I can't really maximize that, but that's master. Your folder changes along with the branches in the code, and that's just that Git folder doing it for you. So you can actually see it in the folder as well. It's not just magic in Git. But it means that you can get that visualization if you need it. The other thing you can also do, like I said, is clear that glow. Git log. That's a log with the changes. I've added a couple of things in there so I can demo it a little bit later on, but these were the steps we did in the slides, and then I've updated some stuff in each of those functions as well. So to merge those changes, no. Right. Check out master, merge the branch you are working on into master. It tells you here what changed. So there's been 2 changes in each of those functions, and these are entirely new. 4 files changed, how many changes were made in total, and then you've still got your SHA-1 hashes up here between the 2 branches as well. The SHA-1 hashes you could probably ignore for quite a while until you start getting into looking into the logs, looking at diffs against previous changes, and when you mess up, you're going to have to start looking at SHA-1 hashes. I'll show you git diff. if I do got isn't a command. Why does Git Log take so long on this laptop? It's a rhetorical question. I don't know why. There's like 4 things in there. So I've updated function 1 here. What you can do is do a git diff that SHA1, the caret, which tells it that's where you want the head at. That SHA1 again. So you can diff that file based on that commit that went in and see what was changed in there. You see a little minus here and a plus there. So this line was technically removed by the way that Git tracks the files. It does delt as effectively. It only tracks the changes that were made in the file. It doesn't sync the entire file. So you can see exactly what changed in that file. I added a line called do stuff here. This came in very handy. About 2 months ago, I got asked if I could have a look at the German infrastructure for some new services we were onboarding. I don't speak German. It was all managed through Puppet, which I've never touched. And it was predominantly running on Linux, which I do very little of. So Q3, 4, 5, 6 weeks of me tearing my hair out, looking through Confluence documentation, all in German, trying to get access to the right resources. Confluence was good in terms of stuff was documented, but it didn't give you routes. It didn't tell you that you could access specific networks from, you just had IP addresses, network cards, that sort of thing. So there was lots of pinging and NS lookup and ICMP was disabled everywhere because why not? So I ended up having to access it through a jump server in Germany, which then I had to access it from that jump server to a laptop, which was in the right network in the office in Germany to be able to access Proxmox and access everything through the console, all because it was locked down via Puppet. So I had to learn Puppet before I could change anything. So my first Puppet change that went in was a firewall rule so that I could actually access it without having to jump through several hoops. Out of all of the information that was in there, there was Confluence, there was documentation, there was build docs, which were 3 years out of date and didn't actually give you any of the right information. Git gave me the most information. The previous Linux admin that was there was really good at documenting what he was doing when he was changing Puppet. Every Git commit message had a Jira ticket. So then I could reference Jira against Git based on what he was doing at that time, found a firewall change, diffed the file based on the Jira ticket number, and I could see exactly what he changed in the Puppet configurations to change a firewall rule. That's how I learned Puppet, via Git. But it shows that when it's done well with commit messages you can reference, the information is all there. So there's also a really cool VS Code extension called Comment Translate. He was very good at commenting his code, which James will appreciate, I'm sure. And if you hover over it, it uses the Google Translate API and translates it all into English for you. So I didn't learn German. I learned Puppet by proxy via Git. And I was able to get access. And then 2 days later, a new guy started and was like, can you give us access? I was like, there you go. 2 hours, what took me 6 weeks. So it just shows you when you start using it and you start learning those inner workings of Git and how it all bolts together, and you start leave meaningful messages for yourself. It's really handy. One of the other things that I blogged about recently, Git, just use tab complete. So I've just created another branch called other branch. All files are in there because it's a branch off master, and I merged all those changes into master. If I do make directory other stuff, you've now got a folder in there called other stuff. We'll check out this one. Say what? should probably commit those changes, shouldn't I? That's it. I've recreated this folder about 6 times now when I've went through it and tested it. New item. Yay! I'll try and keep clear on the screen so you can actually see it. Added other stuff folder. What? Demos, man. Should have kept it all on slides. Check out new feature, new functions. See, it's there all along. So I ran into an issue where I was working with a colleague on a repo. He was doing stuff in AWS, I was doing stuff in Azure. We were setting up pipelines to run off his changes, my changes. I was deploying what I thought was the right layout of the folder structure to Azure to set up some Azure functions. Changed all the layout to what my colleague had in a different branch, pushed it to Azure, failed catastrophically. What I was trying to do wasn't going to work. I had to change the folder structure to have functions in separate folders. But I'd also updated the code within those folders. So any changes I was going to make, I needed to retain his old folder structure, but my code. So obviously the first thing I did was I'll just copy that folder out and then make the changes, copy the folder back in and put the new code in the old structure. And I went through a few different iterations of how to do it, and I was like, I'm going to do it in Git because it's a challenge. And I went through all these scenarios in my head, and it's so simple. So you can do Git, clear the screen again, sorry. Git checkout, other branch, other stuff, did I call the folder? So if you notice, I didn't check other branch out there. I'm still in new functions branch. And what that does is when you check out a folder from within another branch, it doesn't detach the head and keeps it in the same branch, but pulls the folder from the other branch into your current branch. So in new functions now, I've got the other stuff folder. So all I had to do was merge his folder from his branch and then update my code into it. But when I first thought about this, I was like, this is going to die horribly. I'm going to have to delete everything, reclone the repo, rewrite all my code. And I was like, it was so simple. That took me about an hour to find in Stack Overflow. And it was what I mentioned earlier on. I can't remember who I was speaking to about. I've added the replies to comments on Stack Overflow to my ad block because they just confuse situations. Generally, one of the direct comments is the right answer, but then everyone chips in with the little nuances about which version of Git you can do it in. And so I've just looked at the top comments now, and then if it doesn't work, I'll go and unblock it, and it's less distractions. But yeah, so that was another cool trick, which I thought was pretty good. And the one I've showed you just before was Git Log line, which is setting up aliases in Git. Why does it take so long? Yeah. Yeah. So I want that, and pulled it across. No. So this is an alias I've written in Git, which is different from if you do Git clearly my alias. So this is difficult to read, I find. So I've written an alias which is basically 2 switches you pass to Git Log, which gives you a much nicer format and output in the SHA-1 because you can reference just that subbit of the SHA-1 when you're doing stuff. You don't need the full string. So when you're looking through big repositories, what it also enables you to do, which isn't evident in here, is if I do folder mat in ServiceNow PowerShell on my feature branch, it shows you the branches that things came from, which for me learning Git as a non-developer, this was so helpful because then I could see the trajectories different code made. So you can see this is a totally different branch that was merged in. You can see where the commits were, and then my stuff at the top. But I just think visualizing Git in that way helps a lot as a non-developer. As you can see there, it's really easy to get messed up in your branches. I haven't used it very much. Oh, then what's this? Git K. Oh yeah, that's awful. The 90s rang, they want the commands back. But Git K, have you used the new Git Kraken GUI? That does something similar, but in a much nicer current decade fashion. But it shows you all the branches, the commits, and then what I actually like about Git Kraken is you can do a diff on those commits in the browser as well, and it shows you which files and what changed and which lines were changed. But yeah, I did know about that. I just don't like it. Yeah. So I use that a lot as well. That ServiceNow one was actually how I fixed that, was using Git Lens. I could go through and revert specific changes. So in VS Code, do I have it open? I do. Function 1. You've got an extension over here, Git Lens, which gives you all of this stuff down the side. Your branches, one file changed. See what branches are in there, when it was changed. There's loads of stuff you can do in there. And VS Code as well, you get open changes and see recent changes or previous changes. I'll go to previous version or whatever it's called. There, open changes with previous revision. Console. So you can see that line in VS Code if you're using VS Code as an editor. You can see what changed from the last time you committed that, and you can see that this line is shown as removed because I put something on that line. But I personally go for the command line, but all of this is integrated into Visual Studio Code if you have Git installed. You can. I don't like it because it's abstracted away what it's actually doing, and I don't always have VS Code available. So knowing the command line alternative is always more beneficial if you're on a jump box which is connected to a laptop and a Proxmox server through a console in Linux. VS Code definitely wasn't there. So yeah, it's all built in there. It's really handy if you're just getting started because it abstracts a lot of the complexity away. But when you start getting into the inner workings of it, you do tend to need to revert back to using the command line. And that was sort of the only demo stuff that I had prepared. I didn't want to go too far into it. Yeah. You can potentially get in a mess with that as well. One thing I did actually want to cover, which I've apparently deleted the slide for, is, am I still tethered? Yeah. Pushing your code remote. So if we go back in here, yeah, we'll just extend it again. If you create a remote repository on there, when you create it, it pretty much tells you how to back your code up. So I've covered what you can do locally, the workflow you can follow. Logically for me, if you're already doing that locally, if this blows up, you want a copy of it. So I've created a folder in my GitHub called PSDayUK. Git status, git add, git commit. Don't do this at home, kids. You can picture you doesn't like me. Pass me. I hate myself. It basically tells you how to initialize a remote repository up here from one that you've already run locally. So you've already done this. You've already initialized it. You definitely add a README because documentation is important. I'm trying to cross-reference the different talks that's going on. So all you literally need to do is set up your remote. So by copying this line, typing's hard. You've set up a remote repository linked to your local repository. And then the next command is to git push u origin master, and that is basically saying that's the name of the remote and the branch you want to push. Hope I've got data on my phone. Lots of information in there, which is basically it just iterating through everything that it's pushing, where it's pushing it to. It's created a new branch called master, and it's linked your local master with your remote master. You're on branch master, and it's set up to track branch master from the origin remote. You can call that origin whatever you like. If you have multiple remotes set up in, say, Azure DevOps, GitHub, GitLab, you can have all three remotes in there and push code to them simultaneously at the same time, however you want. So you've now got a copy of your master folder in GitHub, which is now backed up. So when I throw this on the floor for logline not working, it's all there. I didn't want to cover too much more than what I've covered already there. I'll put my water down, otherwise my laptop might actually work. Ryan sent this out before. I think all the sessions are in there to provide feedback. I think an email went out as well. I just quickly added this when I seen the tweet. So give you feedback for the event and the speakers for the event. Right, okay. But it helps with next year and evaluating room sizes and how many people were interested in sessions and any feedback for us personally. Like, don't do live Git demos. Any questions around that or about my experience with it all, not necessarily around Git or? So the question was, how are you securing code that's on GitHub? Yeah. You can get private repositories. You can set up things like if you're using Azure DevOps, that has repos, and that can just be internal. So you have to link it to your Azure Active Directory. The same with GitLab, you can run that yourself. You can host it yourself on an internal server. GitHub Enterprise you can pay for, and that's all internal. It's all private repositories. You can set up an organization, and then somebody controls who has access to what, who can push to what. So it's not visible to the internet. but you can still have public repositories on there as well. So you can have your own public repositories in your account, and then an org account, which is totally separate. And then you can link it all to Jenkins, Azure DevOps. It all links in, so you can read from GitHub directly with other tools. Yes? About 5 minutes ago? No. Not very often anymore, actually. And that's partly due to my persistence in making sure that I can solve it with Git. And that's why I blog about the stuff that I do with Git, because 9 times out of 10, you'll run into it once and then you'll not hit it again for another 8 months and go, where was I? So, oh yeah, every time when I first started out, it was like delete, reclone, broken it again, reclone. But I think, investigating how you would do it, searching Stack Overflow for the answers, building up that knowledge, even if you do have to end up recloning it, but just that information, taking it on and how to fix it, especially when you start working with big, large code bases with developers and things like that. With the team, if it's all right when you're doing it yourself, you can mess around with Git as much as you want, delete the folder, and you haven't hurt anyone. Getting good with it locally before you start playing with stuff internally with which other people are going to see. That's why I wanted to abstract the GitHub side of it away, because learning it locally was so beneficial before you started pushing your code and code reviews and colleagues going, who's this guy? What's he doing? Yes? It comes back to the branching strategy, 9 times out of 10. If you've got lots of merge conflicts, the workflow you're following probably isn't working. Whether you and your colleague are working on the same code base and you're trying to merge it all into one, you maybe want to have a look at saying, I'll do mine first, you do yours after, or merge those 2 branches together first before they go into master, so you can resolve any conflicts outside of that. Yeah, it's a case of, yeah, or it's a workflow issue, and then you start having to go down the route of rebasing one on top of the other and cherry picking out certain commits, and it gets very complex and very deep at that point, to the point where you just reclone everything. Yes, Shane? It's what we do internally. You protect master so that you can't push to master. You can commit locally to master, but when you go to push that, it's going to go, no, you have to do this in a branch and raise a pull request.